This next concept that we're going to be looking at together is percent composition. Now, the purpose of percent composition is that it enables us to determine what percent of a compound each element is. So, for example, if I have magnesium oxide, what percent of that compound is magnesium and what percent of it is oxygen? So there are two different ways to calculate percent composition. You can get it from the mass, or you can just get it from the formula. So I'm going to show you how to calculate percent composition in each case. Now I'm going to give you a real world example to explain how to calculate percent composition from mass. So in this example, it tells you that I weigh 120 pounds. If 50 pounds of my weight is water, it's asking you what percent of my weight is water. So if 50 pounds of me is water, what I would do to calculate the percent that is water is I would take 50 pounds and I would divide it by my total mass, which is 120 pounds. Now, to get percent, what I have to now do is multiply it by 100, and that will get me the percent that is water. So I plug it into my calculator, 50 divided by 120 times 100, and I get 41.6666667. So I have one significant figure here, and so I'm going to just make this, instead of 41.67%, I'm going to round to the correct number of sig figs, and so this would be just 40%. All right, so that's how you determine percent composition from mass. You take the mass of whatever you are concerned about, so 50 pounds because that's my weight in water, and divide it by the total mass, which is 120 pounds. If instead of being given mass, I'm instead given just the formula, what you're going to do is you are going to use the average atomic mass. So I'm going to do an example for you. In this one, I tell you you have magnesium phosphate. Now, something that you should realize by now is that if I give you just the formula, okay, the name, you need to actually write out the chemical formula for that. So I'm going to review really quickly just in case you're unsure. Magnesium is Mg, and it has a 2+ charge. Phosphate is PO4, and it has a -3 charge. So if I cross my charges, because magnesium phosphate is an ionic compound, so its net charge should be 0. That's why I crossed my charges. Magnesium phosphate would have a formula of Mg3, PO4. I've got to put the PO4 in parentheses since I want 2 PO4s. All right, so that's my formula. Now, it's asking for the percent composition of magnesium. And so before I actually start with numbers, what that's telling me is I'm going to want the average atomic mass of magnesium, so mass of magnesium, and I'm going to divide that by the total mass of my compound. Now, this is extremely similar to the mass calculation for percent composition that we just did on the previous page. The difference is that now, instead of being given masses, I have to look up the average atomic mass on my periodic table. And so I'm going to do that right now. Magnesium has an average atomic mass of 24.31. And I need to divide that by the mass of my entire compound, which is Mg3PO42. That's why you have to write out the formula for your compound. So I have magnesium, which is 24.31 for its atomic mass, times 3, because there are 3 magnesiums, plus phosphorus, which has an average atomic mass of 30.97, times, I have 2 phosphoruses right here, so multiply by 2, plus oxygen's average atomic mass times however many oxygens you have here, which is 8, because there's a 4 here and a 2 here. So I'm going to put this down below. Its average atomic mass is 16.00 times 8. Actually plug it into your calculator. What you get is 262.87. You put the average atomic mass of magnesium up top, which is 24.31. You multiply that by 100. And when you calculate it, 24.31 divided by 262.87, multiply that by 100, you should get 9.2479. This has 4 significant figures, so I'm going to round this to 9.248%. And that's how you find the percent composition just using the formula.